Hi everyone, I'm Dror helper, as you saw, and I'll be your software developer guide to the AWS cloud. A few words about myself because the previous introduction obviously wasn't enough. I'm a consultant, I write code, usually backend, but whatever I need to. I've been developing software for more than a decade and hope to do so for many, many more years. And I specialize in engineering practices, TDD, unit testing, clean code. I also have a few courses on Pluralsight, if you want to check them out, one of which is about AWS Lambda and serverless applications. I have a blog at helpercode.com, and my Twitter handle is thehelper. Feel free to reach me whenever you want, questions, answers. Tell me what you think about my session. And we're off. Let me tell you a short story about a client of mine. Actually, it became a client of mine after what I'm going to tell you about happened. He had a big server in which he ran several applications and websites with another huge, very powerful machine for the database. And he noticed that he's not handling enough requests. And then came a consultant and told him, well, you should move to the AWS cloud because then you get elasticity and you can use as many resources as you need and you can scale up and scale horizontally and everything will be amazing. And the client did that. And it took a few weeks and they went into the cloud. And then something strange happened. In the beginning, that client noticed something. Although he was in the all-powerful cloud, he wasn't able to handle as many requests as he used to in his own on-premise machine. He came to the consultant, panicked, actually, came screaming at the consultant, told him, what's with this cloud? It's not working. He said, okay, yeah, that's fine. This is the AWS cloud. All we need to do is scale up your machine, put a bigger machine in place, and everything will be fine. And it was for a short while, because one night something bad happened. The database went away, completely crashed, disappeared. And again, the client obviously was panicked about that. And they've checked and tried to find the issue. And we'll get to that specific issue. But again, they scaled up the database and things were okay, at least until the end of the month, when the client got his very first bill from AWS and found out he's been paying a lot of money, a few $100,000, which was enough money to buy another server, essentially. So he wasn't happy. And I came along right after that. And we tried to investigate what was the problem. What's the reason? That didn't really work that well for him. Not as advertised, at least. And we checked and we found a few interesting things about that client's infrastructure. First of all, he used only a single region, a single machine in a single availability zone. He wasn't really using the cloud. He just did the same thing he had in his offices, just paid to Amazon instead of the local IT guys. Second of all the data files, a lot of images, we're talking about few teras of information, was stored using local disk, or in AWS called EBS, Elastic Block Storage. It's elastic, but also very expensive. In fact, almost half of his costs were storage costs. So he used the wrong service there. There were no horizontal scaling. Instead of using many medium-sized, even small machines to handle requests, he used only one big machine. And he couldn't because he was saving everything in this, so you can't scale this kind of architecture. And they used the wrong type of virtual machine for the database. In Amazon, there are many types of virtual machine. They add one every half a year or so. And they were using what is known as the T-class machine. T-class machine essentially are very cheap, but they have this thing called credits, which you accumulate. And when you use them, you sort of get your credits subtracted according to how much time you use that. When you get to zero, after a while, the machine goes away. That's the reason his database just disappeared immediately. And there was no estimation done beforehand. No one told him he's going to pay that much. give them the option to say no, or at least get them prepared for the costs. So in essence, they didn't really use the AWS cloud. They just tried to do whatever they had on-premise and throw it in the cloud. And well, it will work, but not as well. Because when we're talking about the AWS cloud, the real benefit with the AWS cloud is what is known as regions and availability zones. Regions are regions, location throughout the world. You can see there are, I think, 30-something regions right now, 46 availability zones. And every region has one or at least two availability zones. And those availability zones are locations in that country, but they are not on the same exact regional location, which means that if one of them goes down, the other stays up. And basically, when you go to the cloud, you want to distribute your load between several availability zones, and you want to use the region that is closest to your client. And this is, in essence, all you need to plan for or think about when you start thinking about using the cloud, any cloud, not just AWS. And with this great power, this infinite processing resource, infinite storage, there are some things you need to be careful. There are some things you need to be responsible for. First of all, with elastic resources come elastic cost, obviously. You pay for what you use, but you pay for what you use. You need to use the right services, some cheaper than others, some better suited to what you need to do than others. And you want to make sure that if you're not using a single resource, shut it down, throw it away. If you need it, just turn it on again. And that way you can save yourself a lot of money. There's security consideration in place. As developer, I don't like security considerations, but you do need to be aware of that. You can't just put a website in the cloud, expose it to everyone, and hope for the best, because something bad will happen. Someone will get your record, someone will create a denial of service attack or whatever. In fact, one developer read that I couldn't find the blog post beforehand, but he had an AWS Lambda that would give a lot of information out, and he created it perfectly, opened it to the web, went to sleep, woke up the next morning, or in Amazon, $10,000, because someone found his API and started pinging it all the time. So you don't want to do that. And good news is, if you follow AWS recommendations, you're probably pretty good as far as security. There are different performance considerations. Obviously, working with a virtual machine in the cloud, not on premise, things tend to work slower than you expect. And you should take that into account. That's why you want scale. You want a lot of machines, not just one. Virtual machines obviously work not as well as an actual physical machine. On top of that, you can play with AWS offering. You can have a dedicated server if that's what you need, but you need to be aware of that. And you need to know and understand what services you can or can't use. And there's quite a lot of those. And the real problem is how to start, because it can be overwhelming. Start with the AWS cloud, more than 100 services. Where do we go from here? So, getting started with AWS. First of all, create a new account, obviously. Then log into that new account using your root credentials, because that's all you have right now. Open something called IAM, Identity and Accounts Management. Create new users, administrators to create other users, basically. And make sure you don't give any single developer, user, or so on, the administrator user and password. Then log out from your root account and never ever use it again, because that's the only account that you can delete without completely deleting your whole AWS infrastructure or having a lot of conversation with their support. It is harder to delete the root account, easier to delete actual user's account. And it's also a good idea to use two-factor authentication, just to make sure that you're the only one that is able to access that account. Because with that account, you can do whatever you want. and you probably don't want other people to do that. And that's the first service you need to know about, IAM. It's not that glamorous or interesting, but basically allows me to create users and groups, create roles. Roles basically are credentials for AWS services to access other AWS services, and we do that with JSON-based text files called policies. It's a very simple account service. Here we go. This is the AWS Management Console, probably what the first thing you see when you log on. And here we have a nice search, which you should use because looking for a single account can be hard. And if we open that, we open IAM and pray for the internet gods that the connection will suffice. We can see a few things. First of all, you see those green marks here. Those are suggestions that you should take, like creating a multiple factor authentication for your root account. And after you do all those, create your users, you can use this tab here for creating users. Here I have a special user that I'll use to connect for my software. Here I have a user to connect to the console, and a bunch of roles, which essentially is what a service can and can't do, that you'll probably get on later once you start using the AWS infrastructure. And we can see there's a bunch of roles like the Lambda create items from S3 that we used in the training 2 days ago. And that one has permission for full access to SQS, not a good idea, but quick to create, and read-only access to S3 to other services we've used. And then we attach this role to a service, and now we can do those. So this is IAM. And now we're ready to start, basically. And if looking at the AWS console, there's quite a lot there. So I took a bunch of services that I thought you'll find interesting or useful, at least to begin with. I'm not going to talk about IoT or AI or natural language processing. You'll get there if you need to. I'm going to talk about more general purpose kind of services or things that you probably need in the beginning. And the first of which is computing. Computing offering in AWS differ from one another depending on what you need to achieve. You can have EC2. Well, AWS have funny names for everything. EC2 is Elastic Computing Cloud. EC square, basically. Elastic Computing Cloud is AWS way to say virtual machines. So EC2 is a virtual machine. Another option is to have functions in the cloud, AWS Lambda. This is obviously the name and exactly what people expect it to be. And lastly, there's not just ECS. ECS is Elastic Container Service. Everything in Amazon, Elastic and Service, or simple. That's the way it goes. And Elastic Container Service is used to manage your Docker images and your Docker orchestration. There's another one called Elastic Kubernetes Service, which you can guess what it does. And there's another one called Fargate, which will open or create a sort of virtual machine from a Docker image. Those are your Docker services. And the sign in between those is not the IT guy's job. That's the developer architect kind of job. Because depending on which of the services you want to use will change how you write your code. For example, if you want something to run all day, every day, you probably don't use Lambda functions. On the other hand, if you have an operation that will run once an hour, having a full-fledged Docker orchestration with a bunch of multiple Docker images running at the same time is a bit of an overkill, and you'll pay for that. So Lambda is a good idea in this case. It all depends on how long do you need processing and the number of processing or action happening each day, each hour, each minute, each second. For example, with AWS Lambda, which is a very cheap service, you can easily connect AWS Lambda to a bunch of other services and it will run. But if it will run all the time, you'll probably pay around 5 times as much as a virtual machine. Same size virtual machine as what you get from the AWS Lambda. So you have to consider those. The number of running instances is a factor as well. If the answer is 1, virtual machine. If the answer is 1,000, AWS Lambda or Docker images. Although there is auto-scaling for virtual machine as well. It's up to you to decide between those. And finally, the last factor is your DevOps. What are your IT or DevOps people feel comfortable with? If you're a Docker Kubernetes organization, you'll probably go with that. If you don't have any IT or DevOps, you probably want to think about virtual machine and AWS and Lambda. And by choosing one of those, your code will differ from one another. The second service you have to know about is the networking or VPC, Virtual Private Cloud. Virtual Private Cloud essentially is everything networking in AWS enable you to create networks within your account, isolated networks within your account, and distribute IP ranges and have internet gateways and block or unblock certain ports and all this fun networking stuff. There's other two services I wanted to show you, or at least talk about. CloudFront, basically a CDN in the cloud. If you want your website to be available to people in the other side of the world, but your actual virtual machine or whatever gives the website is not there, so you want to use CDN, it is called CloudFront. That way your files are being distributed or cached near your client. And Route 53 is basically Amazon DNS. If you don't have a domain name server, you can get it from Amazon. And again, networking, you have to ask yourself, do you want a public or private network? A public network is open to the internet, to the outside world. A private network does not. Maybe you only write in a bunch of services that will run in their own environment, do some processing, save it in the database. You don't need to open the internet for that. And who need to use your resources? Is it users? Are they going to be authenticated? Is it a specific machine? Is it another subnet in your account? Which resources need to be in the same network so they be close? And finally, what network component do you really need? Do you need a VPN? Do you need an internet gateway? Now, this is, in effect, more of an DevOps kind of work to decide or configure those things. But from my experience, usually you get to ask for it. And in some places, also show them what exactly you mean. So let's see what it means to create a simple virtual machine in AWS. We go to the EC2 management console. That's where we manage networks and where we manage the virtual machines. And in order to create a new instance, you just press launch new instance, and you'll have a quick start wizard where you get to decide which virtual machine you want to use. It can be a Linux or Windows virtual machine. Now, for example, I can choose Amazon Linux, and then I get to choose the type of that machine. And the type of that machine can be either a specific type. Here we have a T type of machine. Those are general purpose, accumulate credits, die if you out of credits kind of machine. And you can look for compute optimized for C5D machines or memory optimized. We start with R. I remember that as RAM machines, and you can have large, extra large, and so on. If we go back, usually I'll start with T2 micro, which you shouldn't use in production, but very good for experiments because either free, if it's the first year you have your AWS account, or very, very cheap. We're talking less than $1. And next, now there's how many instances I want because I can have auto scaling built in. And which VPC to use, which network. I have just one, I'll use that one. And which subnet I want to use. And I can go to storage and decide on the storage of the machine. A machine can have storage. If it doesn't have any storage, you will have some storage on your machine, but once the machine shut down, that storage will be deleted. So we want to keep storage, and we'll use general purpose SSDs. And that's it, basically. And obviously, well, while it's thinking, okay, here we go. This is what you're going to do. Say launch. And now, because it's a Linux machine, I can connect it to a user key, a PEM file, in order for me to be able to connect to it later. I'll use one already exists, or you can create a new one, but you need to save it somewhere safe because otherwise you can't connect to your machine. You need to delete it and start over. And we're done. And we can go and view the number of instances. And this is the EC2 dashboard. Let's just remove that. And we can see there's one machine initializing. I have another machine already running, which is very nice. Now, continuing with networking, basically with VPC, what I can do is divide my environment, my region, into several subnets. I can give my region, a specific region, for example here, US West 2, one of the Amazon regions, and a range of IP addresses. And in each availability zone, I can create one or more subnet and decide whether or not that subnet is exposed to the internet or not, and give it an IP range of its own. And that way I'll create different environments. And those environments can be duplicated if I need to, or can be completely isolated from one another. And by using a load balancer, I can duplicate the same environment twice and have a very nice high availability solution. Because in this case, I have two different regions running the exact same services with a replicated database. And if one of them go away for some reason, the other one will continue working. My client won't notice. I can do that with 3 and 4 and whatever I need. I can decide whether or not those are exposed to the internet or just to other networks, which is pretty cool. And all of that is done almost automatically, because going back here, we can see, pressing on single machine, we can see all of its detail, including public IP and specific VPC. Going to the VPC, I can see what subnet it has, what are the IP addresses, what I can and can't use inside. On top of networking and computing, I need to store stuff. I need to save things either in database or as files. And for that, I have several services. I'm not going to show all of them, just the common ones. The first one is EBS. EBS basically is a hard drive for your virtual machine. It is also, I think, the most expensive one. If you end up with putting a bunch of those in your machine, think maybe you need a better solution. It will give you very fast disk for processing for your virtual machines. Any other objective, any other reason to have it, you're probably better off with one of the other two. First of which is EFS. This is essentially a network share that you can reach from different machines. This share information between different machines, less expensive. And S3. S3 is simple storage service, S3. The simple storage service is very cheap. It has several tiers that you can use. And you can save files in buckets, which are similar to folders in a way, and then access them from wherever you want, from your machine or from the cloud. And you can play with security, whoever can access or can't access that specific bucket. You can also host your static website from S3 as well. It has that capability, and you can save a lot of money doing so. As far as databases, you can use your own database in a virtual machine, which some companies prefer, especially if they have someone to maintain it. But otherwise, you want to use the RDS, Relational Database Service, which has a bunch of databases that you can use and Amazon can manage for you. It has Postgres, SQL Server, MySQL, and Oracle, and several others. And all you have to say, I want a database, these are the properties, go. And you have a fully fledged database to work with. And you don't have to update it. You don't have to manage your virtual machine, but you do have to manage your actual data. And the other option is DynamoDB, which is Amazon sort of document database, highly scalable, can be cheap depending on your load. You get to pay according to how many reads or writes you use per second. and it will be automatic scale, which according to what you configure or set it as auto scale capabilities. It can become very expensive, but in my experience, if you work correctly with it, it's not more expensive with a similar size, similarly distributed database. The other two services I want to talk about, and that's it. SQS, Simple Queue Service. This is a very simple, easy to use, but not very featured queue in the cloud. It will scale automatically, and you get the first million times you access it for free every month. If you want something better, there are better queues. You can use ActiveMQ in Amazon, and other queuing technologies will cost more. If you just need to pass data, that's good enough. And there's SNS. SNS is a simple notification service. You can subscribe for notification and send notification for other services and build a decoupled architecture. Now, all those two, unlike the virtual machine, you need to call from your code. And there are several ways to call data from your code. First of which is REST API. Every single service in Amazon can probably be administered with the REST API. I haven't found one that can't. Or, better yet, use the Amazon SDK. There are Amazon SDK to almost any language out there, at least the popular ones. Java, C#, JavaScript, Ruby. And you can call easily and even administer your virtual machines from your code. You can start them up and turn them down. There are IDE toolkits for Eclipse and Visual Studio that you can use in order to work with your AWS cloud. And finally, you can do that from the command line. From the command line, the Amazon's SDK CLI or CLI SDK. It has a version for Linux, Mac, and Windows. And everything, all of this is very nice, but once you go into the cloud, you start to think about how the hell do I test my code? Because I'm starting to use those services, and I want to avoid calling the cloud each and every time. It requires another account. That's not a bad thing to have an account just for development, or at least use it in a different region, so you don't accidentally cause problems to your production account. But you do want to run things locally, and for that there are several things you can do. First of all, please write unit tests. It's very easy to test functionality in the cloud, especially one that uses other services. Assume that Amazon services work. And then mock them out and write unit tests. Other than that, there are ways to run full integration tests on your machine. There are local implementations that will behave similar to AWS services. There's the local stack by Altesian. There's Go AWS that implements SQS and SNS, the two most common services. There's DynamoDB local that Amazon created that you can actually test with. And there's SAM local to test your lambdas. You can run your lambda functions on your machine. Now, let's see some code. Here, for example, you know what? In order to fully understand, let's look at this first. The flow I'm testing is not that complex, but it's combined from several services and my own service. I have a task service that uses S3 as a sort of database. Whenever you create a new task, it will be saved as a file in the cloud. There's a AWS Lambda that waits whenever a new file is created and put that inside the queue. And I have a local client that will take the information from that queue and just write it on the screen. Now, writing the code, in this case it's .NET, but Java is not that different and JavaScript probably less complex. When I create a new task, I just needed a GUID. I'll create a new request. This is, I got that from the Amazon SDK, that request definition. Added some metadata and call the AWS S3 client for .NET and put the request. And that's it. That's all the code I needed to write. Add some credentials basically, and you're good to go. I can run this. I don't want debugger. There you go. So I created a Swagger UI, and so it will be able to create new tasks. And here I have a queue listener. Queue listener essentially is a very simple program. All it does is, this is maintenance, get the next message, basically connect to the queue and get the next message. That's it. And show it in the screen. And unfortunately, like all demos, and if I go to create new task, I can try it out, create a new task. The title is a test and need to do something. And execute. And if we go and look at S3, a new file should be created there. Here we go, a new file that I can even open. And this is what I sent. And if I'll go to my queue service, then I can see there's a message available in that queue. So everything worked. And now I can run my queue listener. Oh, well. Here we go. It will run, check the queue, and I got my message back. Obviously, it's a very simple example, but it shows you creating this example, this demo took a few minutes, basically. Now, let's say I want to test that queue listener locally. For that, I can use Go AWS. I usually use Docker for those. The reason I use Docker is because it's very easy to get a machine up and running. I have a Docker machine now running my Go AWS, and I can use it with the AWS console by using the right anti-URL locally, and I can check if there's any queues here. I have 4 queues that it created, and now if I go back to my own queue listener and run it, okay, for that, I've added a small define just to run locally with my machine. Obviously, all of you good developers use dependency injection. And now when I run it, it will check the queue and create a new queue locally for me, because it doesn't know that it's not working against AWS. In fact, if I'll try to list the queues again using the AWS SDK, I can see there's a new queue. And now I can send a new message. Forgive me if I don't remember all of those by heart. Here we go. SQS, send message, URL, the queue URL, message body, and so on. And we can see that I got that message locally. So I can run full-fledged integration test with several services locally, and that's what you usually do. We start usually with Docker Compose, or locally start the service, run the tests, throw the service away, and that's it. How much does it cost? Well, before you start your AWS adventure, you should know about this site. This is the S3 calculator, which you should use. It will give you a rough estimate of how much your infrastructure is going to cost. You can compare different alternatives. Usually the architect or DevOps job to do that. And if it doesn't do that, you can do it, because everyone can just press on a link. And start calculating. It doesn't look that friendly, It's not the best CSS I ever seen, but you can add new EC2 instances. And if you want dedicated host, that's Amazon, only yours virtual machine. Costs a bit more, but you get your own environment and your EBS volumes, and you get a rough estimate per month. If you know how much information you're transferring, you get a very exact estimate, and you should use it. Okay, so now you heard about a few services, you heard about a few capabilities. Maybe you want to try it out. Try your new AWS account. You should open one and try it out. And for that, after you create your AWS account, you can do that from Amazon.com free. Your account will be free either way. Doesn't matter how you create it, but there you can see what you're getting out of it. For 12 months, there are several offerings that are free for 12 months, databases, virtual machines, and there are some offerings that are free forever. For example, the first million Lambda calls in your account are free forever. And then there are tutorials and labs that you want to check out. They are very simple 10-minute tutorial in Amazon. Amazon also have a bunch of workshops throughout the world. Look it up. See it in either the blog or Twitter account. They're announcing ones all the time. Probably one near where you live. And finally, there are online courses, some of which are better than others. I know I've used one of the online courses to prepare to my AWS certification exam, for example, which is also a good way to learn about AWS. There are several certification exams, architect, DevOps, and developer. And by learning to the exam, you can take it. Yeah, I needed some incentive. But by learning for the exam, you can learn quite a lot because you have to shove all this information in your head, much better than a 40-minute session. And there are good books, and there are very good exam preparation courses online. Udemy, Linux Academy are the two best ones as far as I know. And that's it. You're ready to go. Thank you. Any questions?